Hey guys, welcome back. Today we are going to be graphing derivatives. So let's review what hopefully you already know. When you find the derivative, let me graph this original function. Parabola we all know and love. Oh, I missed. Something like that. Use your best guess. All right, so it should go through 0, 0. Anyway, what does the derivative tell you about this graph? Well, hopefully you know that it tells you about the slope. Well, the slope here would be 0. The slope here is positive, and the slope here is negative. Okay, so our slope went from negative to 0 to positive. Well, if I went to graph that, my graph has to go from below 0 to positive, and that graph would actually be like this. Well, hopefully that makes sense because you know that the derivative of a quadratic would be a linear, so 1 degree less. So as long as the original function is a polynomial, I know my derivative graph is 1 degree less, and that's easy, but of course it's not going to always be like that. So let me work through how to graph a derivative, and in the beginning, just know that this is not the easiest thing at first, but it gets easier after a while, okay? Also, I put some websites on Canvas today to help you practice with it. Okay, so let me start with an easy one because this graph, the original function, has a bunch of straight line segments. So I can tell exactly what the slope is. So when you're graphing the derivative, remember you're actually graphing the slope. Okay, so in this first chunk from 0 to 1, that slope is up 2 over 1. It has a slope of 2. That means from 0 to 1, my derivative graph should be a constant of 2. Okay, also, at this point right here, that's a sharp point. The derivative doesn't exist there. So the end point of my graph should be an open circle right there. That should be an open circle. I got to redo that. Okay, also at the beginning, that would be an open circle. All right, the next part. The slope of this next section from 1 to 4, that looks like it's up 1 and over 1, 2, 3, up 1 and over 3, so that would be a slope of 1/3 everywhere from 1 to 4. So from 1 to 4, I have a constant slope of 1/3. And it's obviously an estimate. Okay, the next section, from 4 to 6, that's a slope of 0. That would be right here. And then the last section from 6 to 9, that looks like it's down 3 over 3, so that's a slope of 1. So this would be the graph of my derivative, and it has a bunch of chunks because these are straight lines, and in between them, that's undefined. Normally, your original function is smooth and curvy, and then your derivative graph is also smooth and curvy. You're only going to get straight line segments like this if your original function has straight lines. And if you think about it, that's because the derivative of, say, a linear function like 2x, the derivative of that would be 2, a constant. Okay, so this graph of a derivative is not your typical. Okay, let's do another one. What I like to do is first find the slopes of 0 and graph those. Okay, so I'm going to look for a slope of 0. There's a slope of 0 at my maxes and mins. This is a slope of 0 and this is a slope of 0. So on my derivative graph, at about negative 1 1/3, I have a slope of 0, which means graph a 0. That's not negative 1 1/3 though. Okay. Also at about a little bit past 1/2 right here, I have a slope of 0. So a little bit past 1/2 is also a slope of 0. Okay, so that's the first thing. Start with everywhere you see a slope of 0, you graph a height of 0. All right, now I typically do in between those two. The slope between those two is positive. When I say positive here, that means above 0 over here. Okay? So I'm going to go from a slope of 0 to positive, and back to 0. Okay, well, what does that look like? 0, positive, but back to 0 is going to be like that. Now, how high up do I put this point right there? That is an estimate. But what you want to try to do is kind of sort of look at what do you think the slope is at the steepest spot right here. And I'd say it's about up 2/1, but it's a total estimate, okay? It's possible that the correct answer is steeper than that, okay? And this is totally just an estimate, so don't worry too much about that. All right, now, to the right of this 0 right here, my slope is negative. Negative slope means graph it down here on the negative part, negative height. So I'm going to go, once I hit this point, I'm going to go negative, which means my graph would go down, negative. Before this first 0, this is also a negative slope, and negative means below. Okay? Now, you should have predicted that this would be a parabola. If you look at the original function was a negative cubic. So the derivative of a negative cubic would be a negative x squared. Negative parabola, negative 3x squared to be specific, but you don't really know the details. You just know the form. Okay, so I should have expected for a negative cubic, a negative parabola. All right, so go back over that, look at that again. Start by finding your zeros, and they translate to a height of 0 over here. Okay, then this piece is positive, that means above, and the other two were negative, that means below. All right, let's try another one. All right, hopefully you know what this is a graph of. This is a negative x to the 4th graph. So my derivative, I should predict, is going to be a negative x cubed graph. Okay, the details, I don't know. I'm just giving you a general shape. A negative cubic, so I'm going to be predicting something like that. Okay, so here we go. Again, start by finding where you have a slope of 0. Slope of 0 is here, here, and here. And that's going to translate to a height of 0 on my derivative graph. So I have a height of 0 in 3 places. 0, 1.5 almost, and negative 1.5 almost. Okay? Now in between those, between 0 and the 1.5, that is a positive slope. And I'd say it's about up 2/1 again-ish, okay? So I got to go from 0 to positive to 0 again. 0, 0, positive, and back to 0 again. Again, I don't know exactly how high up that should have gone. Maybe it's higher. It's totally an estimate. But what you do have to look at is the left side. Whatever you said the right side was, the left side is symmetric to it. So however high up I put this, I should do the exact opposite on the other side. Okay? They should look symmetric if my original function was symmetric. And since this is a smooth polynomial, my derivative graph is also a smooth polynomial. Now I'm sure you can guess the rest of this is going to go, like I said, probably a cubic. But why does it end up like that? Well, remember, this point here matched this slope. And to the right of that, it went negative slope. So my graph is below 0. On the other side over here, this was a positive slope. And that's why this piece is above. Okay, now I know that looks super messy and you can do a better job than that. But once you get it, the general shape, it should then be smooth and curvy. Okay? Let's try another one. Okay, this one is starting off as a positive x cubed, and the derivative of a positive x cubed would be a positive parabola. So I'm predicting my shape will look like this. Okay? Now again, I got to be clear. They're not normally going to be this easy. Okay, so I got to show you what to do for more difficult ones. But here we go. Find your slopes of 0. Here and here, and estimate where those are, about negative 1 3/4, and perhaps a little bit past 1. Okay, that's my slope of 0. In between those, this is a negative slope, so I go 0, negative, back to 0, and that looks like about negative 1 to me, but I don't really know exactly what it is. I'm going to go 0, negative, and back to 0. Okay? To the right, that's positive, positive. Before this one, that is also positive, positive. And that's why this would be a parabola. Okay? All right, let's try something a little bit more difficult. I guess not. We'll do another easy one. This is still a cubic, so my derivative is going to be a parabola again. Okay, slope of 0 is not just max and mins. Slope of 0 is also flat lines. So if it flattens out, that's also a slope of 0. So slope of 0 at 2. The slope before that is positive. Whoops. So the slope before that is positive, and the slope after that is positive. So positive, positive. But remember, I'm predicting a parabola. Positive is above. So I'm going to say above and then back above. I really don't do a very good job graphing with this fancy pencil. Okay? All right, now we got to do some trickier ones. Not that one. That's going to be a straight line. I'll just do it. All right, slope of 0 here means height of 0 at negative 2. Okay? Again, this is a parabola, so my derivative should be a line. If this is an x squared graph, the derivative is a positive line. So I'm visualizing an uphill line right now. Why does it end up being an uphill line? Okay, I'm going to go ahead and just graph it. I don't know how steep to do it, but it's going to be, should have gone through the point. It's going to be an uphill line of some sort, but it's not a perfect science. I don't know enough about it. I do know that to the right of this, the slope is positive, and that's why we're above. And to the left, the slope is negative, and that's why we're below. But I really don't know how steep to draw this line or anything else. It's just a sketch. Okay, so now we've got something a good bit trickier. Now, first of all, this spot right here, I had to hand draw this. So let's pretend this is smooth and curvy right there. Okay. All right, this might take us a few times to get this one to be right. And I'm going to graph my derivative graph right on top of this rather than draw another coordinate plane. You can do it right on top of it or draw a separate coordinate plane. Okay, let's first find our slopes of 0. There's a slope of 0 here, 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 here. Over here, we are approaching 0, but not there yet. That's important. Okay, slopes of 0 that are clear-cut would be here, 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 and here. Now, again, to the right, we're approaching 0, so I want to keep that in mind. But this is a negative slope, so below the x-axis but approaching 0 means I'm probably going to be over here. And if this were to continue to go like this, then that definitely pretty much gets flat. So I know I'm approaching 0 but doing it from the negative side, okay? Because, again, this is a negative slope, so we do it on the negative side of 0. Okay, so I know I'm going to pretty much have like an asymptote here approaching 0 from the bottom side of it. All right, in between, this is a positive slope right here. So my graph's going to go from 0 to positive to 0. So I'll go from 0 above and back to 0. After that point, now we've got a negative slope. So I'm going to connect with a negative piece. Then I have a positive slope, but much steeper. Back to 0, because remember, we've got to go back to 0. Then I'm going to go sharp negative and back to 0. Sharp negative, back to 0. The only piece I'm missing is over here was positive. That's above. Okay, this is sort of a mess to look at. Okay, let me try again. Make it a smooth curve at least. So we're above and 0, then above, back to 0, below. Maybe I should draw this one for you on a different coordinate plane. Now, some things I need to point out. I'm going to erase all of this. Okay, now, we know that this is a positive slope, but this is way more steep than this guy. So when I graph it, this one's going to go up somewhat, somewhat, but this one should go up a lot higher. Compare one to the other. Okay, Similarly, this is negative, so I know my dip has to go below the x-axis. But this is way steeper, so this dip should go even lower. Okay, I'm going to try to redo this one again from the start. Okay, let me try that one again. So my slopes of 0, -2, a little bit in between. Here are my slopes of 0, and again, this one is getting close to 0, but on the negative side. So on my graph, -2 is a slope of 0, so about -1/2, another one here, in between here, and over on this other one, this is going to be a slope of 0 also, but keeps going at 0, okay? Because we're assuming that this is going to flatten out, sort of. All right, connecting them. This piece is positive, so it's 0, positive, 0. That's this. This piece is negative and steeper than this piece was. Okay, this piece is super positive, and then negative again, but back to 0. Negative and back to 0. And then over here, this was positive, so I got to loop back up. Okay? Make it smooth and curvy, but believe it or not, that's approximately what it looks like. Okay, let's try one more. Okay, slope of 0 here. So I know I definitely have a point here. But slope of 0 also over here, just like the last graph, and it's going to hang there for a while, stay at 0. It doesn't just turn around like a max or a min. So it's a slope of 0, but it's also a negative slope getting to 0. So that's going to do this. Stay at 0, and stay there, okay? Over here on the left side, that's a slope of 0, but a positive slope. So it's on the positive side, but hugging 0. That's going to do the reverse, kind of like this. Okay, and it's an estimate. So don't feel like it has to be perfect. Then connecting this 0 to this 0, we have positive slope. So I'm going to go negative, I'm going to go 0, positive, back to 0. Well, this graph is symmetric, so whatever I chose to do here, I just got to do the same thing on the other side in reverse. So, approximately like that. Okay, this is why on the on Canvas I gave you 2 websites where you can practice with these graphing derivatives. Okay, guys, good luck. Let me know if you need any help.